The Battery Buzz podcast is brought to you by H.B. Fuller Company. H.B. Fuller is one of the battery industry's leading suppliers of adhesive, encapsulant, coatings, and sealants for the EV and battery industry.
So hello, everyone, and welcome to Battery Buzz, the show for battery professionals by battery professionals, keeping you connected to what's new with batteries and the people who help build them. Your battery specialist hosts today are Elizabeth Canaz and me, Jermaine Maria Selvaraj, and we are back today for another episode. So let's get started. Glad to see everyone here. Thank you for joining us. This week, we're super excited. We're welcoming our special guest, John Warner with American Battery Solutions. So we're looking forward to our discussion with John and learning more about him, his books, and ABS's contributions to the battery space. So great to have you, John. We're really excited.
Thank you so much. I'm excited to be here.
Yeah, so give a little history on John. So Dr. John Warner is a thought leader and an author of 3 seminal books on lithium-ion batteries. That's impressive. The Handbook of Lithium-Ion Battery Pack Design, first and second editions, and Lithium-Ion Chemistries. He holds a Doctor of Management and Organizational Leadership, an MBA in International Business, and a Bachelor of Science in Industrial Management. And John is also the Chief Customer Officer at American Battery Solutions. So welcome, John. That's quite a background.
Yes, thank you so much. No, I'm excited to be here. It sounds like I don't take any breaks. Trust me, I get a vacation now and again.
Once every couple of years, right?
Once every couple of years. But the books are done usually. That's usually the long process, is getting the books written. Then I get time to take a vacation.
That's awesome. Well, welcome. And we're looking forward to learning more about what your knowledge and about the industry itself.
Yeah, absolutely. Yeah. Well, before we kind of dive into that, John, usually we like to start kind of a segment where it's what's new with batteries and kind of just go over some news and current events in the EV and battery world. So the first thing that I noticed that I wanted to talk about was I thought it was interesting was Lucid. So, it was no secret that some of their early edition models, like the Dream, kind of started out at a very high price tag for, the luxury EV, but it's interesting to see that their prices for their models. So I think they're offering a cheaper Air model, which is around $57K. And I think I just saw in the news, they're planning to have some sedan options come out that they're trying to go sub 50. So super interesting. And based on their earnings call, I think they're developing a lot of innovations in their EV powertrain with smaller batteries. And so it's lighter weight and continuing to dropping the price. So yeah, it's very interesting, to see that shift from them, especially.
Yeah, they were pretty expensive.
Yeah, well, and I think that's really key for a company like Lucid, right? To be able to grow, you got to get out of that $100,000 range and into the mass market. So getting below that $50,000 mark really starts to open it up. I think the average vehicle, EV and non-EV price in the U.S. is around $36,000, $37,000 right now. So as they start to get below that sub 50, now opens that up to a much wider audience.
Yeah, definitely.
Yeah, and they're not, being secretive, they're trying to compete directly with, I think they said the Tesla Model 3 and the Model Y. So it's, no secrets there why they need to reduce the price.
Yep. Tesla set the benchmark, haven't they?
They made it tough for everybody. So another interesting thing that I was reading about is BurgerBot. So there's a company called Serve Robotics that's paired up with Uber Eats to roll out autonomous robot deliveries for Shake Shack. So Uber Eats customers in Los Angeles may have their next Shake Shack order delivered to them via an autonomous robot. So they'll be going down the sidewalk as Serve Robotics. And since the new partnership with this fast food chain, they'll deploy around 2,000 robots in LA to deliver meals. So it's going to be pretty cool to be kind of, futuristic looking, I think, having these bots roam around town.
Yeah, no, it's an interesting trend. We're seeing, robotics is a huge growth market right now for electrification and for batteries, right? We're seeing it everything from warehouse robotics to we're working with a couple of customers working on autonomous lawnmowers, right?
Oh,
So everything from those to the food delivery markets. It's an interesting market. It's going to be interesting to see how the consumers and the pedestrians react to, to the autonomous robots working around on the streets there. The
Yeah.
technology is there. That's easy enough to do. So we've just got to make sure that the human robot interaction remains strong and a positive one.
Yeah, I know I'd move to the other side of the sidewalk if I
Yeah.
saw one of those, not gonna
Yeah.
lie. I don't know if I could go head to head with one.
Well,
So
it's
I
there's videos out there of people like trying to tear them open to get the food that's inside, breaking into them. And so it's going to be interesting to see how these things can survive. And if we get through
Yeah.
that kind of reaction of people, not being comfortable with them. So once we get comfortable with them, I think it becomes everyday technologies, just like your appliances in your house. But I think we've got probably a short period where people are just not used to seeing those types of robots out in the streets.
Yeah, and I think I was talking to, I wish I could remember the name of the company, but they do the programming for the autonomous,
Mm,
vehicles. And I was asking him, I guess they just runs the same scenario over and over again for the robot, and then it remembers the exact route and it does everything the
yeah,
same. And if anything goes wrong, it just terminates and it doesn't do anything.
Mm.
So it's not going to run you over. It'll
yeah.
just terminate and just sit there. So unfortunately, your food will be warm and probably not edible, but you won't be killed
Yeah.
by the robot.
But at the same point, to the kind of the article, comments, you're also not going to be using a 5,000-pound vehicle to deliver your two-pound burritos, right?
Yeah.
Yeah,
Yeah.
that's an interesting juxtaposition there. Yeah.
Yeah.
But yeah, so the other thing that I saw in the news that was interesting was about a company, Hexagon Purus. I think their value proposition as a company is super interesting, but I saw that they entered a multi-year supply agreement with Gillig, and they're the second largest transit bus manufacturer in North America, so pretty huge. And this is kind of on their hydrogen fuel cell
Yep.
storage system, so the supply for that. And I think those storage systems are for their Gillig's new line of fuel cell powered transit buses. So I thought that was super interesting. It's you have multiple countries now that are entering these kind of hydrogen agreements to kind of reduce their carbon footprint, and hydrogen is the way that some people think is the path forward. So it's interesting to see big companies like this kind of have partnerships, and it's all in North America as well. So
Yeah.
very cool.
Well, if you look at the fleet and commercial vehicle space, when you get up to those class 7 and 8 vehicles, very big vehicles, very heavy vehicles, fuel cell starts to make a lot of sense, right? So the challenge with fuel cell for consumers today is that there's no infrastructure, right? Where do you go get your hydrogen? But if you run a depot of buses, you can have the converter right on site there. So it now makes more sense to be able to do that. So I think where you're going to see, the adoption of fuel cells is in those fleet applications where they come home to a central depot and where they're using bigger vehicles, class 6, 7, 8 trucks, delivery vans, transit buses. All of the transit bus makers are launching or looking at, for at least some portion of their markets, fuel cells. And you see a lot of the municipality bids that go out. They include multiple technologies, from battery electric to hybrids to fuel cells. So you're really seeing this combination of solutions hitting the marketplace.
Yeah.
On the positive side, they still take batteries, so I'm good.
Yeah, there's still a battery in them.
There's still a battery in there, so I'm good.
Exactly.
And I know I've talked to a couple of like trucking companies, and the challenges they have is, it's exactly what you said, the fueling stations, and they have cheaper prices if it's their fueling station, but if they have to go to a third party fueling station, the price could be triple. So that's a good point. Like in Gillig, fun fact, is about 5 miles from my house. So it's manufactured in Livermore.
Yes.
Very cool.
They are.
I didn't know that they were family owned. I thought that was very
they are,
interesting.
nearly 100-year-old family-owned company, still privately held. So the second largest transit bus maker in North America. Excellent company. I've talked with them many times in various different organizations. So they're still certainly doing some great stuff, from transit buses, trolley buses. They've got a lot of electrification they're looking at there. So really good company. So glad to see them adopting some of the fuel cell technology.
Yeah.
Absolutely.
Well, let's dive into this and get to know you a little bit better, John. So I am really curious. So what inspired you to write books on lithium-ion battery pack designs and chemistries? Like, where did this idea
Yeah.
come from?
Well, it was. I'll tell you the story. So when I started in the battery industry, way back in 2009, I joined a company called Boston Power, and I left General Motors for it. And I knew about batteries, but I didn't know batteries, right? So I knew that we needed them for hybrid vehicles, and that was about it. So I came into a small company called Boston Power, and I read everything I could find out that was on the market. I bought every book I could. Some of them were not even relevant, but there was not a good single book that I could look at and say, okay, now I understand it, right? What are the bits and pieces of the battery? Anytime you're moving from one industry to another, one of the questions come up is, what is the terminology? You got all this jargon you use. What in the world is a watt hour, and why do I care? And so that kind of stuck with me, and I read a lot. And then they'd partnered me with an engineer when I started there, and it was a great partnering. Guy's name was Dr. J.R. Lynn, a fabulous guy, and he helped educate me. So we'd come out of a meeting, and I'd say, "How did you calculate that?" And I had a little book, and I would write down all these formulas. And fun fact: for about 3 years, I thought I invented Ohm's law. I said, "Wow, this is great! All these formulas connect."
No,
Turns
I
out
did.
I did not invent Ohm's law. I was a couple of hundred years too late. But I kind of rediscovered it on my own as I went through asking those questions. And that's really what I did. I asked a lot of questions, and then the idea for the book came out of, and I can still remember it clearly. I was with Magna at the time, and I came out of a meeting, and one of my purchasing guys said, "Gosh, John, man, how do you know all this stuff?" And I said, I asked so many questions. I just read a lot and I studied a lot. And I was sitting thinking, I said, I bet it would be nice to have a tool like this where somebody could pick it up and said, I need to understand the basics of thermal management systems or whatever technology. So that was kind of the impetus for the first book. And you say, as we talked about earlier, I kind of lovingly refer to it as, what do I wish I knew when I started in the battery industry? And that's really what it is. It's not an engineering text. It's not designed for you to walk away as a battery engineer, but if you're a transitioning engineer, you're a thermodynamic engineer, or you're an electrical engineer working on engines or on communication systems, you could pick this up and you could walk away with enough of an understanding of the technology to speak well about it, to understand where you fit into it. It's going to tell you about the terminology, the basic formulas, all of the kind of stuff that you need to know, including what are the subcomponents of a battery system and why do we need them? What's a BMS and why do we have them? And then where do we go? What are the markets? What are the testing? And then what does the future look like? So that one published initially in 2015. I just finished a second edition, which published in May of this year, which was a significant growth of the book. I think I added about 40% new content to it. From 2015 to 2024, the industry's evolved so much and has changed. As I started looking at it, it's like, boy, I didn't just update it. I rewrote every single chapter and I added 2 new chapters into it. So that's how much the industry has changed in the last 10 years.
Yeah.
So I was really excited for that one. And then the second book, which is called Lithium-Ion Chemistries, that's, again, another fun story. I was, 10 years into the battery industry, and I was sitting here one day thinking to myself, and again, I've got an MBA and a Doctor of Management Organizational Leadership, right? So I'm not a physicist, I'm not a chemist. But I've always been in engineering organizations. And one of my skills has always been kind of, I like to say, translating from engineer to real people. And so that's what these books kind of do. But I was sitting home one day and I remember looking back and says, I've been selling lithium ion batteries for like 10 years. And I was sitting there asking myself, what in the world's an ion? And then I got out my good friend Google and I looked it up. It's an atom, it's lost or gained an electron. It's like in 10 years, nobody has said that. Nobody has ever said anything that simple. And it's that simple. It's a atom that has lost or gained an electron. That's what an ion is. And I sat and I said, if I'm wondering that, I said, I bet there's a ton of other people who would really like to have a basic understanding of this chemistry. So I took, and this was a really fun book for me to write, but I took on the task of trying to write a chemistry book without any chemistry formulas. I use a lot of visuals in it. I use a lot of descriptions. I try to make things very clear and easy to understand. being technically accurate, but not being a chemistry book, right? So you could pick this up and walk away and say, I have the basic understanding of how the chemistry works and why they're different. Why is a lithium iron phosphate chemistry different than an NMC? You know, what are the things that make them different? Where do the materials come from for these things, right? So some of that kind of stuff. And that was really where the second book came from, was that idea of just trying to really help bring a higher level of understanding to some of these technologies to the industry and the world.
Yeah, and I know just from talking, like I started in the battery industry in 2018,
Mhm.
and there wasn't a whole lot of books out
No.
on the market. I know there was one that one of the engineers that I work with had. It was like it was old and tattered, and he had gotten it from somewhere. And he's like, "This is the book." I don't remember what the book was called. It might have been your book for all I know. There wasn't a lot of content, so I
Yeah.
think it's great that you're putting the content out there and educating the
Yeah.
consumers, because I think even consumers don't know a lot
Absolutely.
about batteries in
Yeah.
general, and the chemistry, and what's good about it.
Yeah, and that's where these books come in. They can be a great intro to batteries course. I've done some of those at both this company and other companies we've done. They're great for government officials. They're great for investor groups, right? So if you want to understand the basics without having to be a chemist or a physicist or a mechanical engineer, these are great tools to help you. And they're designed so you can pick them up and pick a topic, right? You don't have to read them front to back and say, I need to understand cathode materials. Let me look at that chapter. Or I need to understand, again, BMSs, or I need to understand the charging infrastructure. And you can pick a chapter and kind of focus on whatever subject you're trying to educate yourself on. So I think they're pretty successful. We had a lot of good feedback from people in the industry that have read the books, and I'm always open to recommendations. I will probably take a break before I try to do anything else. I find it takes about a 18 months to get from start to finish in one of these things. So by the time I'm done, I'm ready for a break. So
Well,
Sure.
congratulations.
thank you.
That's awesome.
That's awesome. Yeah. And yeah, I mean, I should probably read these too. I mean, it's not just for people and consumers, but even in the industry, like you said,
Absolutely.
there's so
Yeah.
much. Sometimes,
Yeah.
you touch your part of the battery world, but
Yeah.
there's other parts, that we might not know anything about.
Absolutely. And that was really
It's
the whole
cool.
idea, right? Is that you're going to be an expert in the materials H.B. Fuller makes, right? And you know those inside and out. But what about the mechanical design of the battery pack? You're going to have interactions
Yeah,
with that, or the thermal management system, right? Or some of these other components. It'd really be nice to sometimes have that. And we've got so many great technical experts in the field coming from other areas, and it's really just that introduction to give them that background so that they can come in and hit the ground running.
absolutely. Well, that's awesome. Awesome. That kind of shifting from your books, your career it's so prolific, it's and so widespread. It's amazing. But right now with American Battery Solutions, do you have kind of an overview of their
Yeah.
journey, kind of from start to finish, or where you're at now with the battery manufacturing industry, and kind of what they're doing today, and how it is different from when you started?
Yeah, so it's a really good story. I'd say it's a success story. The battery industry has been rife with startups that have come and startups that have failed, and this is the fifth startup that I've been with. And so I am really excited with where we're at today. We started back in, it was really 2018. Our founder and CEO Subhash Dar, he called a bunch of us together, probably about a dozen of us, and he said, "Hey, I've got this idea." Right, and he kind of started introducing us, and it was fun. He was at the time living in downtown Birmingham, and there was a little coffee shop there, and we called that the first office for ABS. He would bring us all down there, and he would buy us coffee, and he would say, "Here's what I'm thinking about," right? And we actually had an investor engage him and said, "Hey, I want to make an investment into this side of the industry. What do you recommend?" And so Subhash kind of put together a roadmap. Said, "Well, here's what I would recommend doing." And he said, "By the way, I've got the team to do it." He didn't have the team, right? We hadn't started the company yet, but he called us all up, said, "Hey, we got this idea. Will you come support me?" So we also met for 3 or 4 months, Saturdays and Sundays, putting together a business model, putting together a proposal, present to this investor group, and they loved it. They said, "This is awesome. Let's go." And during that process, we had actually another again. Sometimes you see things falling like dominoes, and this is one of those cases. While we were negotiating to raise the first round of capital, we got a call from the president of Bosch Battery Systems saying, "Hey, Subhash, I know that you know a lot of investors. I've got some assets I want to sell. Can you introduce me to some?" And Subhash said, "Well, no, I'll buy them from you. And so we had an opportunity right at the beginning to buy the plant in Springboro, Ohio. So we got 170,000 square foot factory on day one. And then we were able to step into about a third of the facility in Lake Orion, Michigan, which was all of the battery testing equipment. So we took over a battery testing lab installed up, ready to running. And then from there, we actually acquired the rest of the building in Lake Orion, Michigan during COVID. As Bosch was kind of consolidating some of their resources, we were able to take over the whole building. And so now we've got 120,000 square foot in Lake Orion, Michigan. We've got the 170,000 square foot down in Ohio. And we really kicked off work at that point. So 2019, we started the company. We started developing some low voltage products, really with the idea, let's get into a market quickly that doesn't necessarily require the validation that an automotive or a larger battery would take. So we developed a family, we call it the Alliance family of batteries. Initially, there was a 48 volt, 2 kilowatt hour. We, through some customer feedback, we evolved that into a lead acid drop-in replacement. So now we've got this 24 and 48 volt, 3 kilowatt hour batteries, highest energy in that form factor in the industry. And they're a drop-in replacement for things like golf carts or light electric vehicles or utility carts. We're seeing a lot of really great adoption in things like golf carts. We've got 2 different golf cart customers working with us to electrify their solutions. At the same time, we started engaging with customers. And we started telling them the story. We started building the team, pulling the team together. And we won our first 2 projects in 2020, right? So while the world shut down, this is our kind of our running joke. When the world shut down in March, we got about twice as busy. I think everybody finally had time to start writing RFQs for batteries when COVID came. So we were inundated with RFQs, and we started responding to them. And we won the first big project we won was with New Flyer Industries. So we talked about Gillig earlier. So New Flyer is the #1 transit bus maker in North America. In addition to the fuel cell stuff they're doing, they are significantly moving towards a fully electric fleet. So they've got some very aggressive electrification growth targets, and we are now supporting them in that. So we kicked off development of a new battery for them. We started low volume production last year, and now we're in the volume ramp. So we are building that in Springboro, Ohio today. We are running 2 shifts, as a matter of fact, and we're getting ready to start a 3rd shift in support of these guys. So we're really excited about that one. At the same time, we won another program. Unfortunately, I'm not yet at liberty to announce who it's with. We are negotiating with them very hard to be able to announce it, but it's a last mile delivery van program, which is going to ramp up to volumes of 15 to 20,000 units per year by about 2026. So we just kicked off a 2nd production line, which will give us nearly 30,000 high voltage pack unit capacity by 2026 when this is fully installed. So we're really excited for those. At the same time, we're working with some smaller customers. We developed a family of off-the-shelf battery packs. We call it our ProLiance brand of batteries. And it's the first product is a 350 volt, 50 kilowatt hour battery in production, ready to go today. You can ship them tomorrow if you need them. And then we've got a second variation of that one, which is a series capable version, meaning that I can do a 700 volt, 100 kilowatt hour block. And we're seeing some really good adoption. We're working with a yard truck manufacturer right now that we hope to be able to announce in the very near future, who is going to be adopting ours as the sole battery that they'll be ramping up with over the next year. So we've got that in a wide variety of applications and products, ranging from kind of mobile energy storage units to industrial equipment. So those are all ramping up today. So it's been a great journey. And I would say the most exciting thing happened, and of course, as a startup, the biggest challenge is always raising capital. We had a phenomenal investor when we started the company, a group that was focused on our type of organization, finding a leadership team and supporting that leadership team. But typically their model is you grow it to a point where it gets big enough where a larger company will take and acquire it. And that's exactly what happened. When we were ready to start raising capital, we were approached by Komatsu Limited in Japan. Komatsu is one of the largest manufacturers of construction and mining equipment in the world. And they've got some amazing targets to reduce their CO2 emissions. So they want to be 50% of their 2010 emissions by 2030 and net zero by 2050. So really aggressive targets, which is going to require a lot of electrification. So they knew in order to accomplish those goals, they were going to need to have a battery partner. And part of the challenge that they faced was their volumes are not automotive volumes, right? They build vehicles in tens of units per year. right? 100
Yeah.
units a year is a big program for them. So
Yeah.
again, as a independent battery maker, it's hard to justify the investment in a program like that, and they recognize that. So they've came in and they acquired us outright. We are now a wholly owned subsidiary of Komatsu America, technically, and we are supporting them. We're already engaged on 3 programs. 2 of them are with an underground mining vehicle. One of them is with an above ground mining vehicle, and then we're looking at their next generation of batteries for their construction equipment. And what we're focused on right now is trying to give them a common solution. And this is really where the value we can provide is. We look at all their vehicles and say, let's see if we can give you one solution that you can scale and use in not one vehicle, but you can optimize 5, 6, 7, 8 vehicles. And so that's what we're at right now is we're looking at how do we do that so that we can give them a cost-effective solution that allows them to meet the needs of their customers. And so as of December 1st, we were acquired. We're now actively working towards it. We're heading towards our first year. December 1st of 24 will be year number 1 anniversary. And so we just returned from a trip to Japan. They are very excited about us. They're still trying to understand the battery industry, but that's what we're here for, to help be that center of battery expertise for them. So
Well, it
we will
sounds like
continue
there's
to
a lot of exciting things going on, for
absolutely,
ABS. So
absolutely. Yeah.
Yeah, they're in good hands, I can tell. Komatsu is in good hands. So
And it's a great goal, right? So we've got dual targets. We're gonna support all the Komatsu electrification, but we're continue to grow in the commercial vehicle space and in the fleet
yeah.
space. So we've got these dual targets which really feed off each other. So as we do new and innovative stuff for the slightly higher volume applications, we can transfer some of that knowledge and learnings in some of the Komatsu. So they take advantage of some of that. So it's really good. And of course, now we can share the volumes. That was always one of our benefits when we started negotiating cell supply agreements. Was as a small pack maker, it really needs to consolidate many different programs to become a bigger buyer with the cell players, to be a bigger player. And that's what it allows for Komatsu as well, because their volumes
Yeah.
would have been really small.
yeah. And that's a huge challenge, I think, for a lot of battery manufacturers. If they don't have the high volumes, it's hard to
Yeah.
get the cells that you want. So, yeah. So I guess, I'm curious, just as with all of your depth of knowledge and experience, what do you see coming down the pipeline in the next 10 years for batteries? Like, where do you see this whole industry growing and
Yeah.
evolving? And I mean, what trends do you kind of see going on?
Yeah, that's a great question. And 10 years is a long time in the battery space, right? So like I said,
Yeah.
when I wrote my first
It's
book, it
like
changed
dog years.
entirely in the 10 years, right? So 10 years is a long time. So there's a couple of things I think. First of all, it's important to note that the technologies we're using today are still going to be around. 10 years from now, we'll still be making 2170 cells. Same way we're still making 18650 cells today. So there shouldn't be a fear that you're going to get replaced by doing that one. Now that doesn't mean new technologies aren't going to be emerging. We're already seeing the 46 family of cells, 4680s, 4690s, 4695, 46120s already starting to emerge, and we're seeing some of the automakers starting to transition to those. So, I think we'll see more of those coming. That really allows you to look at a cell to pack technology, which some of the HB Fuller products are really going to support with a larger cell. Cell to pack with a small cylindrical is a little difficult to do. You really need to add that structure in, but the cells get bigger. It now makes more sense to be able to do that one. So we're going to see more and more of that on the automotive side. We'll move towards those 46 family of cells. You're also seeing, LFP getting reintroduced in the automotive space. When we think about automotive applications, we're probably going to see a divergence in technologies, right? So for that entry level $40,000 vehicle, do I need the very expensive, 100 kilowatt hour battery? Probably not. You can probably get away with a 40 or 50 kilowatt hour battery, right? So I think what you see is LFP and maybe even LMFP, lithium manganese iron phosphate, in addition to lithium iron phosphate, emerging as that entry level vehicle. So I think you'll see that that becomes the starting point for a lot of electric vehicles is that LFP, LMFP. And then as the range gets higher or you get to a more premium class of vehicle, you move into that tri-metal nickel, manganese, cobalt, or nickel, cobalt, aluminum chemistries. So higher energy density chemistries. And then, if we're looking 10 years out, you're already seeing, companies like Toyota announcing their solid state batteries, and Mercedes-Benz even today were articles about them working on some of their solid state technologies. I think you'll start to see those getting launched in really low volumes, ultra premium applications, the end of the decade, 27, 28, 29. There's still some challenges to overcome. It's a great technology and holds a lot of promise, but there are both technical challenges and there are supply chain challenges that we still need to solve when it comes to solid state batteries.
And
Um,
manufacturing challenges.
and manufacturing challenges.
Mhm.
Yeah, I mean
Scalability.
there's a ton of issues.
Yeah.
But it's got a really great potential benefit. So number one, you're taking out all of the liquid electrolytes. Safety is the number one challenge for batteries today. We've all seen all the incidents in the news. So if you take out the liquid electrolytes, then there's no liquid to be flammable. Now, there is a whole other issue with solid state batteries. Now you've got a lithium metal foil in there, which is highly reactive with water. So now, the question is, how do we inform all those first responders out there? Don't douse it with water, right? Because now it's going to have the opposite effect. So there's some learning and training where we have to figure out how do we start coating the lithium foil? Are there other things that we need to do to manage those? But we'll figure that out. That's what the battery industry does. We innovate, we'll find solutions for those. But the benefit is going to come when you start seeing a $20 or $30 per kilowatt hour solid state cell, because your energy is so high, your cost per unit becomes very low. So that gets you to that really cost effective sub $100 per kilowatt hour pack. So that's the promise, I think, of solid state. A lot of challenges for us to get from here to there, but a lot of really, really great companies working on it and a lot of investment going into it right now. So I'm confident the industry will start to move towards there. The
So
other
in
thing
10 years, we'll bring you back and we'll have to verify.
absolutely. I
We'll
mean, you
see how
also
close
got
you
Five
other,
more
reach us.
books in.
yeah, absolutely. And you're also seeing things like sodium ion starting to get a lot of focus, right? We got two or three companies, including CATL, has launched sodium ion batteries. Probably not a great fit for your high volume, or at least your long range EVs. But let's think of a city car that's going to be working in Beijing and it may run 20 miles a day. That might be a perfect application, or your light electric vehicles, right? So I think that 2 and 3 wheeled, electric vehicles could be a great fit for something like that. And of course, stationary systems and those types of areas. So I think you'll see that technology evolving and getting better through the years. And I was even just reading an article about manganese oxide, a battery that's been developed over in Japan with 840 watt hours per kilogram. It's like, that's fabulous. Now, again, I need to see the research and kind of the show me. We get I would say, a lot of fantastic announcements from the media about things that are happening in the R&D phase. But I always try to remind everyone that from the time lithium ion was invented, Stan Whittingham and John Goodenough back in the mid 70s, it took over 40 years before we commercialized it in the auto industry, right? It was something like 42 years. So it takes a long time to commercialize a new technology. So just keep that in mind anytime you see one of those fantastic articles of something that's going to replace lithium ion. Is it maybe, but it's probably 20 or 30 years out before you see that happening.
Absolutely. No, it makes sense too, right? I mean, with good reason. There's so much that you have to take into account. That's such a huge shift to, globally, so many different, industries. It makes sense of why it takes as long as it does.
Yeah, absolutely.
But when the shift happens, it's huge.
Yeah, and some of the things out there, like, so there's a lot of work going on in aluminum air, 1,000 watt hours per kilogram. Awesome, that's great. But it's cycle life is zero right now. The only companies that are able to use it are actually having to replace the aluminum plates. But it's one of those ones that you figure out how to commercialize an aluminum air battery at 1,000 watt hours per kilogram. You are now at 10% of the energy density of liquid fuels. Now we're a player. Right now, your battery is starting to get a quarter of the size that we're looking at today. But that is in that 20 to 25 year out range, before we start seeing those, other than in demos and kind of stuff. Those are the things I like to keep my ear to the ground on. Got magnesium ion, right? Magnesium. We think of that being a flammable material, but the energy density with it is pretty amazing. In addition to lithium metal, you got a lot of great work happening right now with silicon anodes. I think that'll be the other thing we're going to see emerging over the next 5 years. Even is a real growth in the silicon anodes. I'm seeing technologies today which are claiming at least equivalent cycle life performance at nearly half 50% or greater of the energy density, sitting at 350, 400 watt hours per kilogram and getting 1 to 2,000 cycles. If they get to that, I mean, that's a winner. That's a game changer. So I think there's a lot of things which are getting very, very close to starting to really drive us to the next level of technology industry.
Yeah.
Yeah, I think
Well, I think,
sorry, go ahead.
oh no, go ahead.
I was just say the resources. So like with some of these, new, elements or,
Yeah,
technologies, having the abundance of resources,
yeah,
raw materials is
yeah,
critical in driving these. And I
yeah,
think that'll drive us to these to explore more and spend
yeah.
more resources and money on these.
Absolutely. We talked about, if you remember at the beginning of the century, we talked about energy independence, right? So we're talking about our
Mm.
oil independence and all that kind of stuff. We need the same energy independence today. And that was one of the reasons the IRA was so important for us, right? Is that we've got to have access to those minerals. And those were things like, again, the sodium ion, the lithium sulfur batteries start to get really, really interesting because we've got all those minerals here, right? We've got all access to all that minerals here today. So I think it's a really good move for us to continue moving towards that way. We've got to have energy independence in the battery segment too.
Yeah. Well, what I was going to say is, I think it's important for companies like American Battery Solutions and, for people like you, John, who are just keeping a pulse on all of these
Yeah.
changes, and for ABS probably to be able to adapt, as the industry is
Yep.
changing, and kind of, making it sure that all these new technologies as they come out, as they get tested and whatnot, being able to implement them. I think you're in such a unique position with
Yeah.
your value proposition and your size and what you've got going on, that you can kind of go any direction that you need to.
Yep. And that's a great point. One of the things, that about ABS that is a bit unique is we've got a lot of in-house testing. So we do a lot of it, Eric Anderson and our whole testing team there, we've got over 300 channels of cell testing. So
Wow.
we're always testing not only our current cells, we've got
Yeah.
2 years worth of data on the cells we're using today. But we're also looking at new cells, new suppliers, and new chemistries, new technologies. One of the companies that I work with is called Soteria Battery Innovation Group. And Soteria is working on safety technologies. And they're working with companies like Nanotech, who has got a flame retardant cell. So essentially a cell you can push a nail through and it won't go into thermal runaway. And that's what Soteria is all about, is creating those safety technologies. We're able to get those cells and we're able to test those at an early stage and give those cell makers feedback so that they can keep developing them. And that kind of can help guide their product directions, right? So they're producing cells and technologies that are going to, at some point, merge into the things that we're doing today.
That's
Yeah,
awesome.
we had Soteria on our last month's episode,
Yeah.
learning
So
about their
Brian
safety
well then.
programs.
Yeah.
It was perfect. But yeah, so I mean, and all this, and speaking of American Battery Solutions, we heard you got a third line for both your
Yep.
Alliance product line and then the Pro Lines, which you talked about, right? Which
Yep.
is in Ohio, which I think is great. Other than that, any other plans in 2025 for ABS or
So
anything new?
2025 is really a growth year for us. We will be ramping up our second, so we will be running just about at capacity, in 2025, which is a phenomenal place for a battery startup to be, first of all. But our first phase of line 2 will come into production at the end of the year in 2025, and we're going to put it in 3 phases. One of the things with being a small company is you got to think about how you spend your capital, and so rather than putting in a big chunk of money in one front, we'll put in a little bit, let that get filled up, and then put in the next stage. So we'll kind of keep that rolling that way. So line number 2, which is going to be really dedicated to our second big customer that I'm not able to announce yet. They're going to run up to 15, 16, 17,000 units per year. So we're going to put in a line with about 21,000 unit capacity. So it gives a little bit of float and flexibility, and then it'll give us an ability to run some other stuff down there. But what that means, it'll open up line 1 capacity now. So by the end of 25, when we transition that customer over, we'll have some additional capacity on line 1. So we're looking for those next big customers, those other transit bus manufacturers, school bus manufacturers, work truck manufacturers that we can start, partnering with to be able to get our products launched into them. At the same time, we are, kicking off development of new technology. So one of the things, that we know our portfolio is lacking is like a lithium iron phosphate today. So we're hoping that by the battery show this year, we'll be able to announce a partnership that we're negotiating today. But it'll give us access to a LFP cell, which will be manufactured right here in the U.S. And that means I can get a Buy America compliant battery pack with more than more than the 70% or 75% minimum requirements built right here in the US. So we're really excited about that. And that opens up a whole new market for us because there's a lot of places where NMC is a great technology for, but really LFP is a better fit. So that will offer our customers a second solution, which is also going to be designed to fit in a little different packaging portfolio. So, we want to make sure we're hitting the between the rails here. So we're going to make a narrow kind of short height pack that you can easily stack as you need to. So, so we're excited about that. It'll probably not hit the streets until late 26, early 27. We're going to make sure we do it right. We're also going to take all of the best of what's happening in the world. We want to look at a cell to pack solution for this. Since we're going to a prismatic cell, it's going to necessitate yet another manufacturing line to be able to weld that cell. So as we go away from this, as we add a prismatic to it, we need a different welding technology. So we'll go back to a laser welding for that. So as we add that capacity in, we're going to be looking for, those first lead customers that want to work with us and help us optimize the design for them. So that's going to be a lot of our jobs in the next year is to get those customers online, get them engaged, and really start driving that development for our next gen products. And then beyond that, I hope we're starting to add, that 46 family of cells as our Gen 2, part of our Gen 2 families.
Awesome.
That's
exciting stuff.
Yeah,
I know.
It is.
You guys have a lot of exciting things happening.
We definitely do. I said earlier on, this is a real success story. You've seen a lot of battery companies come, sprout up, and then disappear over the years. Some of them faster, some of them, hung around for a lot longer. I think with the backing of our great partners at Komatsu right now, and they are so supportive of us. I can't emphasize, what a great company is to be acquired by. They are looking to support our growth and support. They understand as a small manufacturer, we're learning as we ramp up, and so they've got resources, quality resources, supply chain resources, engineering resources that they're applying to us and saying, hey, how can we help you? Not how do we take over, not how do we run, but how do we help you grow your business? And so it's been a phenomenal partnership, and we're really excited to see that continue to grow over the next few years.
That's awesome. Well, John, it's been great having you. I think, I've learned so much, and your career and, and everything that you've done and what you've experienced was very fun to listen to. So thank you.
Excellent. Thank you so much, Jermaine. It's been a pleasure being here. Elizabeth, it's been great talking with both of you. So I'm hoping to hear more, and we'll see you at the battery show.
Absolutely. So ABS will be at the battery show, right? So
we'll be there.
I believe your booth is 4018. So you'll be there along with the ABS team. So hopefully people come visit and chat.
4018. We'll have the whole team there. You can come see some of our products and talk to some of the great folks.
Great. Awesome. And H.B. Fuller will also be at the battery show. So John will definitely have to connect and meet each other in person.
Sounds good.
Yeah, but me and Elizabeth will also be there with the rest of our awesome team. We'll be at booth 605. So we're excited.
Sounds like biggest event of the year. Bring your dress shoes.
Exactly. But so with that, that's all the time that we have today. So I want to thank everyone for joining us. You can join us next month for another episode of the Battery Buzz podcast. We're excited. We're going to have special guests, Shane Brody and Andrea Bartolini from Canon USA, an equipment supplier. Very exciting. So they're going to be joining us to discuss what they're doing in the battery industry.
Awesome. Sounds like an exciting event.
Yeah.
Yes. And if you have any comments or questions on today's discussion, feel free to comment and give us your insights. Please subscribe, like, and follow, and check out our electric battery adhesives page on LinkedIn. Until next time.